You have an application case requiring more than 2 DAC EV12DD700. You want to start the evaluation of the synchronization capacity of the EV12DD700. You can start evaluating 2 EV12DD700 synchronization capacity with our evaluation board and the associated GUI. Here is an overview of the EV12DD700X 2DAC EVM evaluation board, giving access to the 2 EV12DD700 DAC, 2 RF outputs, and the GUI, allowing you to easily configure its digital capabilities. In this video, I will give you all the information you need to get started with the EV12DD700 2DAC evaluation board for output alignment between two separate DACs. So let's start by setting up all equipments. A Teledyne Liquid Lab Master, balloon for clock, balloon for signals, DD700 dual DAC product board and power supply, PC with 2 network cards to access GUI on the internet and to connect to the PC. In this video, I will give you the demonstration of the capability of EV12DD700 DAC to be synchronized one with another. This permits to manage generation of multiple aligned signals between more than 2 chips. Here we will compensate the small mismatch to the DD700 DAC being slightly different between one another. The DAC DD700 is able to start in 2 configurations. First, if the 2 cores start independently. The second, if the 2 cores start simultaneously. Here, in our case, we are using the second solution. The DD700's core starts simultaneously, meaning the latency first data parameter will be the same between the 2 cores of one DD700. The FPGA will read the latency first data register of each DD700 chip and calculate the difference. After that, the FPGA will apply this difference of delay to the data sent to the 2 chips, so their output are time aligned. Now let's get started. Plug Ethernet cables and power supply cables. Turn on the product board using the general switch. Check that the network card is configured correctly. In my case, I open a command window and enter a ping with the board IP address. Then I copy-paste this value in the research bar of a web browser. Now that the GUI is launched, inside the GUI, perform a reset of both DACs. To do so, select each DAC, DAC1 and DAC2 to perform a reset. We choose to use the EV12DD700 in 8-bit mode. For the clock, we go in the board tab and enter, for our case, 10 GHz and choose the internal reference clock. SDA parameter is 32. We can then perform a loop alignment using the button. Trigger eye centering. Do not forget to hit the sync button. In case of a frequency change, it is mandatory to perform a trigger eye centering anew. Now we can start to configure the pattern to generate. To do so, we go in the Pattern Generator tab. We must select, circled by yellow, the chord chosen for the pattern we are generating. For this example, I chose a sinus signal form and I enter anew the 10 GHz sample frequency. This must be the clock frequency value used. Click Use configured values to acknowledge your pattern is defined. Apply pattern. Then select Play a pattern once or play it continuously depending on your application. Here we can visualize on the scope the 4 sinus not aligned. We will now use the multi-core synchronization tab. Do not forget to unclick automatic synchronization. Using the sync shift buffer delay for each core of the 2 DAC, we can align channel by channel the signals. Here we can see the 4 sinus perfectly aligned. We have reached the end of this video. You have learned how to get started with the evaluation board of the EV12DD700 2-DAC EVM to generate up to 4 signals time-aligned. The evaluation board is available, so you can start your developments right away. If you have questions or if you are interested on the EV12DD700 2-DAC EVM, please contact us using Teledyne E2V hotline email address.